the first point of Libra. That's what these are all imaginary points, Aries and Libra. So now let us assume at the beginning of our story, just to make you understand, if the Earth is here, if the Sun is here, what happens when the Sun is here? Its declination is 0. So this declination of the Sun is 0. This is Sun's rays fall equally over the Earth. Because declination 0, as you can see, सब equally गिरता है sun का. Places thus have equal days. ये लिखो, ऐसा लेबलिंग करके तुमको लिखना है when you are drawing the diagram. Equal days and equal nights. This is known as vernal equinox, and this is a spring season. And it has spring, बाद में spring से मत लिखो. It occurs on 21st March. Every 21st March, this occurs. Now what happens? This is apparent path of the sun. The sun is going in easterly path. Like Earth is going in easterly, so Earth को change कर दिया, तो sun जाएगा easterly. So अब sun is moving up, its declination going on increasing, because as you know, the declination is the arc of the meridian between the body and the equinoctial. तो ये हो गया declination. Declination बढ़ रहा है. Finally, sun यहाँ आ गया. Summer season is going on now, because as the sun goes up more and more north, more rays will fall in the northern hemisphere. Northern hemisphere is warmer, and that is summer season. So now let us come to the end of it. Declination is maximum. Maximum declination of sun. That is 23 degree, 26.7 minutes north. This is the maximum declination of the sun. Sun's rays fall more on northern hemisphere. Because northerly declination, no? More on northern hemisphere. Longest, okay, this is known as summer solstice. Summer solstice. Longest day and shortest night in northern hemisphere. And it occurs on 21st June of every year. So this is what it is. Now as the sun moves further, its declination will start reducing, and after a particular time, it will come over here. At the first point of Libra. Again, the same thing, we can just, what we do, we copy this here. Of course, you have to write, you cannot copy. I can afford to copy because I'm using the whiteboard. Again, declination 0, falls equally, equal days and equal nights. This is called autumnal equinox. Autumnal equinox. And it occurs on 23rd September. 23rd September. ये हो गया था. This is also known as the autumn season. This is called the spring season. That is known as the autumn season. Now we come to the next one. This again we can just copy and just change the parameters a bit. ये हो गया 22nd December. This is what is called the cause of season. Now we will come to the written work. ये साउथ हो गया.
सर ये विंटर सोलेस्टिस होगा ना?
हाँ करेक्ट.
Sir, which point is this?
I will show you. Winter solstice. It is when it is at the southernmost point of its journey. Yeah. So here what happens, more
northern hemisphere.
सर ये साउथर्न हेमिस्फीयर होगा.
longest day and shortest night. नहीं, it will be the reverse. It will be the longest night. We are referring with northern hemisphere. Longest night and shortest day in northern hemisphere. Shortest day in northern hemisphere. Because more of sun's rays are falling in the southern hemisphere, less on the northern hemisphere. Here the sun's rays fall more on southern hemisphere. अभी देखो ये. Winter solstice, longest night and shortest day, 22nd December. Now I will come to the notes part. Once you finish with the diagram and writing the labeling, you can start with the notes.
So the autumn equinox, it is 23rd September and March.
23rd, obviously not March, September. March को निकालना पड़ेगा. कट पेज का है. That way कट पेज नहीं करना चाहिए. 23rd September, 21st March, 21st June, 23rd September, 22nd December. Remember these days. हो गया?
सर थोड़ा लिख रहे हैं सर.
हाँ लिखो लिखो कोई बात नहीं. Take your time.
Sir, in this case, we consider Earth as stationary and Sun is moving around.
Correct. Longest night and shortest day in northern hemisphere. Shortest day ना winter में. Summer में longest day हो गया ना. ठीक है ना? Okay, now ready to write? Everybody? Okay. Always write for purpose of navigation. Purposes of navigation. The Earth is considered to be at the center of the universe. To be at the center of the universe. With its axis vertical. The sun therefore appears to move along its apparent orbit called known as ecliptic. Known as the ecliptic. I'm writing so that जो थोड़ा slow है लिखने में they will be able to catch up. बार बार repeat करने का जरूरत नहीं. Sun therefore appears to move along its apparent orbit known as apparent easterly orbit. Easterly orbit known as the ecliptic. यहाँ तक ठीक है?
Yes, sir.
Okay. Referring to the figure, let the sun be at the first point of Aries, that is the intersection of the equinoctial and the ecliptic. That is our assumption. इसको मैं निकाल रहा हूँ अभी ये नीचे. The declination of the sun then is 0. 0. Its rays fall equally, same thing repeating, over the earth, and places on earth experience equal days and equal nights. This is known as vernal equinox and occurs on 21st March vernal equinox. This is the spring season. So ये है cause of spring season. Now we come to the next one. Slowly I'm removing all the which are already written, so we have place. Can I continue? Let me know when you're finished and I can continue. आज मैंने तुम लोगों को क्या बोला, कितना बजे तक क्लास होगा, कुछ बोला था?
Yes, sir.
कितना बजे बोला था?
17:30.
Ah, yes. Good. Good that you remember, so that I don't have to repeat myself. Take care. Now let's start. Now, again, now as the sun continues on its easterly journey along the ecliptic, it's northerly, it has a northerly declination. Ecliptic. It takes, or it has a northerly declination. Places in the northern hemisphere receive more sunlight and experience summer season. On 21st June, the sun attains the maximum northerly declination of 23 degree 26.7 minutes north. यहाँ तक करो. खाली वो डायग्राम ड्रॉ करके ये रिटर्न नहीं करने से तुमको 25 नंबर मार्क्स, तुमको 30 मार्क्स से 10 मार्क्स मिलेगा. ये फिगर और रिटर्न करने से तुमको 25 मार्क्स मिलेगा. That is important to have the written as well as even when you're doing a ship construction drawing and all that. That question may be sketch and label, but still remember you have to write something. So be very careful. That are the tricks to gain more marks in past exam. This is known as summer solstice. Summer solstice. And occurs on 21st. अच्छा तो लिख दिया. And places in the northern hemisphere experience longest day and shortest night. ये हो गया your summer solstice. Done. Okay, next. The declination of the sun starts reducing the declination of the sun starts reducing as it moves towards the first point of Libra. Gradually, the autumn season sets in. On 23rd September, the sun is at first point of Libra and its declination is 0. Places on Earth receive equal sunlight and experience equal days and equal nights. Equal and experience equal days and equal nights. This is known as autumnal equinox. ये autumnal equinox. Let me know when you finish writing, then I can continue further. Right, next part. As the sun continues its easterly orbit along the ecliptic, its declination becomes southerly. Places in the southern hemisphere receive more sunlight, while the northern hemisphere receive less sunlight and experience winter season. On 22nd December, the sun reaches or attains its maximum southerly declination of 23 degree 26.2 south. This is the winter solstice. And occurs on, it occurs on the whole year. And places in the northern hemisphere, no. And the northern hemisphere experiences the shortest day and the longest night. That's all. Everything done. Declination बोल दिया, 22nd बोल दिया, more sunlight बोल दिया, winter season बोल दिया. You have to put in all those words. That's all.
Excuse me, sir.
बोलो.
Sir, ये last line on second December the 18th.
The sun attains. Yeah. On 22nd December, the sun attains its maximum southerly declination of 23 degree 26.7 minutes. This is called winter solstice, and the northern hemisphere experiences the shortest day and the longest night. Any doubt, anybody?
Sir, in this cause of season, do we need to define the this first point of Aries and first point of Libra in the question?
जैसे मैंने क्वेश्चन में लिखा वैसे लिख दो.
Okay, sir. If in the exam it asks the definition of first point of Libra and Aries, so what can we write, sir? Like exactly to the point, because though both the points are cutting at the ecliptic and equinox.
तो अभी बोला वही है, but anyway I will give you separately. Don't worry.
Okay, sir.
Sir,
हाँ बोलो.
sir, why we take this northern hemisphere as we are saying when it's summer in northern hemisphere, taking it's summer season. But why not? But it's in southern hemisphere it's winter, sir.
Because summer is when there's more sunlight falling, no? So northern hemisphere winter है, northern hemisphere summer है. Our reference is northern hemisphere because all the pandits used to stay in the northern hemisphere, no?
Okay.
साधन में कोई तुम्हारा अफ्रीका एंड साउथ अमेरिका ऑस्ट्रेलिया ये सब कोई था ही नहीं. But the main Pandits were there in Europe and all that. Not even US. Europe was the main hub of astronomy, you know. That is why all the Kepler's laws and all those important people that you can think of are all from Europe. That is why it's always northern hemisphere. Nobody bothered about the southern hemisphere.
And so why its name is Libra and Aries? It's like that.
कोई पंडित बोला है रिसेंटली, पर अभी वाई इट इज नेम बड़ा मुश्किल क्वेश्चन है. ये टिपिकल ओरल क्वेश्चन है. यू कैन अप्लाई फॉर ओरल एग्जामिनर पोस्ट. बराबर ओरल क्वेश्चन. ये मैं भी सोचा नहीं ऐसे पूछने के लिए. ठीक है, नेक्स्ट टाइम आई विल आस्क. यू आर टेकिंग एक्सपीरियंस टू बी द ओरल एग्जाम्स अभी से ही.
No, sir, this no.
Now you're thinking like that, huh? Good. So anyway, why it is named? Is it because those अभी जैसे तुम बोले कोई flower, why the flower is named? Why you are named in with whatever name you got? Why somebody is named as that? Because some pandit has named them. That's all. So ऐसा कोई logic नहीं है name में. ठीक है ना? So now we can come to the last part. Now the sun moves in its apparent. Now the sun moves along its apparent easterly orbit and reaches the first point of Aries and reaches the first point of Aries when its declination once again becomes 0 and vernal equinox occurs. वो पूरा स्टोरी बताने का जरूरत नहीं है. ये हो गया. So this is what it is. This is called cause of seasons. इसमें एक और डायग्राम तुम ड्रॉ कर सकते हो if you want more marks. You might have heard one song that नाच मेरे बुलबुल तो पैसा मिलेगा. ये सॉन्ग सुना है कभी? हिंदी सॉन्ग सुना कि नहीं?
Yes, sir.
तो सिमिलरली जितना नाचोगे उतना पैसा मिलेगा, जितना लिखोगे उतना नंबर मिलेगा. That is what. So that is the concept of the exam, is that the more you write and the more diagrams you draw, the more marks you get. That's why I'll give you one more diagram, which is like this. This is a realistic diagram. ये वहां पे तो सन को बेचारा अपैरेंट ऑर्बिट में भेज दिया था. ये एरीज को भूल जाओ. ये एरीज क्या कर रहे हैं? अभी सन इज बैक इन इट्स माइटी पोजीशन. इट इज एट द सेंटर. ये सन है. अर्थ को हम लोग चारों दिशा में भेज देते हैं. ये ईस्ट में है, ये नॉर्थ में है, वेस्ट में है और ये साउथ. द axis of the earth is tilted towards. इससे कोई मतलब नहीं है इसमें नॉर्थ साउथ में. इसमें मतलब है ये ऐसे. ये वर्टिकल है दोनों, because it is you are seeing from the middle. So what you are seeing is that in this case and in this case, here more sunlight will come in the northern hemisphere because sun's light जो है that falls at this angle and this angle. So as you can see, more sunlight is falling in the northern hemisphere, and in this case, more sunlight is falling in the southern hemisphere. That is why here it is having, when in this month of December, northern summer, northern winter, southern summer. Here it is northern summer, southern winter. That is what it is. Right. Let's not waste any time and proceed to the next topic.
इसमें कुछ लेवलिंग नहीं करेंगे सर?
हाँ नहीं ऑलरेडी मैं
Leveling.
लेबलिंग कर दिया ना. You can say what you can, in short you can say that this is declination 0. Simple करो declination 0. This is from going towards winter, so it is September, vernal equinox. Oh, so ज़्यादा पूरा करने जरूरत because you already done everything, no? No, this is autumnal equinox. You can write the date also, 23rd September. Yeah, record declination 23, 26.7 north, 21st June, summer solstice. Yeah, उसको उल्टा लिखो, declination 0. Vernal equinox. March. Here you can say declination 23, 26.7 south, 22nd December, winter solstice. Okay. Both the diagram you can draw, or you can draw the first diagram, but first diagram is mandatory. That is the in detailed diagram. Yeah, this is only for further explanation. Can I continue?
Yes, sir.
Yes, sir.
Okay. Now we come to the very important subject known as Kepler's laws of planetary motion. Introduction is Kepler's laws explain the motion of planets around the sun. First law. All planets revolve around the sun in elliptical orbits. With the sun at one of the foci. This is the first one. Very easy. इसका डायग्राम भी ड्रॉ सकते हो तुम, हर चीज में डायग्राम ड्रॉ करो. सन को थोड़ा साइड में कर दो, and the planet को यहाँ कर दो. So what you are defined? And the planet को यहाँ कर दो, हो गया. Elliptical orbit दिखा दिया. Sun is offset because foci is the locus, you know. Is the main. There are two. Every ellipse has got 2 points where the sum of the distance will be the same between the 2 points will always be constant. That is the definition, textbook definition of ellipse. Not required. Just draw a simple diagram and that's all. Now law 2. Second law. The radius vector sweeps equal areas in equal intervals. The radius vector of the planets sweep equal foci. It's a plural. Focus is foci is the plural. Focus is the singular. One of the foci. दो foci है, एक में sun का position. I don't know that as per definition of ellipse, that the distance between the two foci to the orbit is always constant. A radius vector of the planets sweep equal areas in equal intervals of time. इसका थोड़ा definition रहेगा. इसमें you have to define by drawing the ellipse and drawing the sun जब perihelion है, perihelion is the time when it is closest because equal area चाहिए, so the arc will be more in equal interval of time. Here, because it is long further away, the arc will be less. So if I say that this is P1, this P2, we are defining its in time t because this area A will be equal to area A dash in time t. A dash in same time t, we see that the planet from in the same time it will have a larger angular momentum, larger angular motion at perihelion than at aphelion. This is the planet and this is at perihelion, this is aphelion. Diagram draw karo, then when I give you the notes it will be clear to you what I want to say.
सर ये डायग्राम एक बार और एक्सप्लेन कर दीजिए.
Here the sun is at perihelion, P1 to P2. That means pass में, closest. Perihelion means pass, closest. The area A, because the radius vector sweeps equal area and equal interval of time. So this is A and at the same time it is A dash. So as you can see, because this is longer, no, so automatically the one side will be lesser. So therefore it is moving more at perihelion than at aphelion. So it's rotate the orbital velocity will be more at perihelion than at aphelion. That is what it means. I given you the definition of perihelion and aphelion.
नो सर.
अच्छा ठीक है, एक नोट में लिख दो. As and when we come, we will define perihelion. Perihelion is when the planet is closest to the sun. P pass में, that's all remember. Aphelion is when the planet is furthest from the sun. Same way when you come to Earth, it is called perigee and apogee. Perigee is when the Earth is closest to the sun. Perigee pass. Apogee is when the sun is furthest, or when the earth, sorry, not when the sun, we are talking about earth only, when the earth is furthest from the sun. That's all. Those are simple explanations. As and when we reach some new topic, you can keep asking, I'll keep giving the definition. Done? Okay, now with your explanation, referring to the figure, when the planet is at perihelion, it moves from P1 to P2 in time t. At aphelion, the planet will move from P3 to P4, covering the same area in time t. Thus, at perihelion, its angular motion, angular displacement is more, and thus its orbital velocity will be greater than at aphelion. Thus we can sum up and say planets move faster when they are closer to the sun. Means sun डंडा मारता है और वो जल्दी भागता है. Than when they are that's all. This is the explanation of Kepler's second law. And that is the synopsis. Done? Anybody has any doubt? Now we come to the third law. Third law. Kepler's third law. Bolo?
Sir, this angular displacement and mobility velocity can you explain to me?
At perihelion it is more, no more angle is covered. And thus orbital velocity is greater. Same time, no? Got it? So doubt क्या है?
Sir, what do you mean is angular displacement and orbital velocity? Why it is more?
Because it is close, the area is the same, no? Since the area A, I showed you the diagram, the area is the same, but the angular velocity is greater because in time t, no, it has to cover more area, but it's closer to the sun, no? So it has to move faster to cover the same area. That is what it means. For diagram समझ के तब बोला नहीं, दोबारा diagram दिखाना है क्या? ये देखो. Same area, no? This area A is equal to area A dash. Equal area and equal interval of time. But ये डंडा कम है ना, तो automatically ये ज्यादा है. It means in a triangle to maintain the same area, if two sides are same, the third side has to be greater, no? Yes or no? This is a spherical triangle only, same way, because this side is greater than this side. Therefore, P3, P2, P4 will have to be smaller. That is what it is.
Yes, sir.
Okay, now we come to third law. Third law. the square of the distance of the planet from the sun is directly proportional to the cube of the square of the, sorry, not distance, 1 minute, time period of revolution. Time period of revolution of the planet is directly proportional to the cube of its distance from the sun. Therefore, we have we can say that T square is directly proportional to dq, or we can say T square by dq is equal to what? Constant. Or I can say T square of a planet like Earth upon d cube of Earth will be is equal to, so let us consider another planet, say Venus. We will give you T square of Venus upon d cube of Venus. D cube of Venus. इसमें एक छोटा सा न्यूमरल भी आता है. We'll do one numerical, which once you do, you'll be able to do all others. कभी कभी ब्लू मून में आता है. Question is very simple. If Venus makes one revolution around the sun in 227 days, calculate its distance from the sun. Anybody has any idea? ये क्वेश्चन एमएमडी में कभी कभी आता है. वेरी इजी क्वेश्चन, 12 नंबर का क्वेश्चन है. इट इज वेरी इजी मेथड टू गेन 12. सो इन दिस केस वी नो, ये सब लिखने का है. वी नो करके आई एम राइटिंग हियर ऑल्सो, आई विल रिपीट. वी नो ये करके नीचे से सब लिख दो. डिस्टेंस ऑफ अर्थ फ्रॉम सन is equal to 93 million miles. Earth makes one revolution around the sun in how many days?
365 days.
बाकी 0.25 कहाँ जाएगा? वो तो लीप ईयर में हम लोग एडजस्ट कर रहे हैं. एक्चुअली 3.25 days. Therefore, you can now write, we want the distance ना, dv cube, d वो क्यूब में बाद में लिखता हूँ बाहर जाके. dv cube is equals to tv square into d. अच्छा, ये इसको छोटा कर दो, Venus etc. छोटा कर दो. वो स्क्वायर, द क्यूब एंड स्क्वायर आई विल राइट, बिकॉज आई कैन नॉट, यहाँ पे ऐसे नहीं कर सकता है व्हाइट बोर्ड में. tv cube is equal to tv square into divided by t square. divided by TE square. अभी जाके मैं square and cube लगाता हूँ, so it'll be easier. D cube of Venus equals to therefore dV is good. Directly you can do distance of Venus. तो ये करो और देखो कितना आता है. T take time of Venus as 225. 225 square into 93 लिखो. The answer will come in million. 93 cube divided by time period of Earth 365.25 square is equal to inverse cube root. Answer कितना मिला? I got 67.33 million miles. मिला? Anybody got it?
Sir, Venus is 227 days, na, in the question.
Huh?
Venus, sir, you said 225, but it is written in 227 days.
227 days Venus. वो क्वेश्चन में दिया कभी 225 देते हैं उन लोग. That whatever they give you have to take. But main idea they want to know whether you know the third law and how application of third law. Durganandan Pandey, you got it?
Yes, I got it, sir.
Srirag TP, got it? चलो वो है ही नहीं, सो रहे हो. Harshit Anand, you're doing it. Harshit Anand, got it?
Yes, sir.
Martin Rajan,
Sir, doing, sir.
okay, good. Do it, tell me, and then we will go on to the next one, which is the last topic for the day, which is apparent motion of the sun. Then by that time it will be almost 5:20, and then you can go out. Tomorrow we'll finish out a little bit of theory for that. Then we can get on with the practical part. Or tomorrow let's do some practical. Khali theory ka we will become bored. So we'll do some theory tomorrow. Some practical. Have you all got your nautical almanac ready? With
Yes,
hard
sir.
copy?
Yes, sir.
Because tomorrow we'll need it. Fatapat we'll start doing. Once you get practical is very easy, it is interesting, and it is easy to score marks. But principle of navigation is difficult, it is conceptual, so concept kabhi clear nahi hota hai, kabhi mug up karna padta hai. But I try to make it as practical as possible so that you can understand everything, so that you will not be that much confused. If you're confused, you tell me and I will clear it. Right, can we move on now from this? Can I clear the board, everybody?
We will have to by heart the values of this distance from Earth and Sun.
अरे अर्थ का तुमको मालूम है, तुम लोग ज्योग्राफी किया ना 93 मिलियन माइल और 365.25 क्या बाय हार्ट करने का है, वो दोनों मिल गया, वो तीसरा तो दे ही रहा है 227. ठीक है ना? 93 मिलियन माइल्स, आई डोंट थिंक यू नीड टू बाय हार्ट, राइट? बाय हार्ट करना, अभी बाय हार्ट करो, 10 बार बोलो डिस्टेंस ऑफ अर्थ फ्रॉम सन 93 मिलियन. 365.25 आल्सो यू नो, ये सब क्लास 8 ज्योग्राफी है. ठीक है ना? नाउ लेट अस कम टू व्हाट इज कॉल्ड अपैरेंट मोशन ऑफ द सन. This means apparent motion in the celestial sphere. This is why it becomes confusing. Because normally what we see, sun is rising in the east and setting in the west. But that is not the apparent motion I'm talking about. I'm saying within that rising, it is moving, as you know that kabhi wo idhar jata hai, somewhere declination going on north, south, so it keeps moving, the east and west points keep changing. For that, let us first take the celestial sphere. And then we take the Earth's orbit. Then we take the Earth's orbit. This is the Earth's orbit. And then we take the sun in the center. Sun in the center. And we consider the Earth to be in 5 positions. The Earth is here, 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 Yeah. Now we can name them E1, E1, E2, E3, E4. All diagrams should be drawn with a protractor, compass, etc. E5. Yes. First I'll explain to you, then I will give you the notes. When the Earth is at E, the Sun will be seen in the celestial sphere at S1. Also, this question is define apparent motion of the Sun. Another question is explain why the SHA of the Sun. I defined SHA last time. No, what was the SHA? SHA definition में किया कि नहीं? Okay, then before that, let me just explain. Okay. So I will just define SHA quickly. SHA is the angle at the poles, at the celestial poles, or arc of the equinoctial between the first point of Aries, between the meridian of the and the equinoctial, or arc of the equinoctial. Between the meridian of the first point of Aries and the meridian of the body measured westerly from Aries. That's all. Textbook definition, SH. And RA, same way, right ascension. Is easterly angle between Aries and the body. Obviously, it will be equal to same definition. RA is equal to 360 degrees minus. That's all. Got it, everybody? Easterly.
रीड आउट कर देंगे.
हाँ बोलो बोलो.
Can you please explain the diagram?
नहीं अभी हम SHR आ रहे हो गया. Then we go to the diagram.
Yes, sir.
Yes, sir. हो गया वो.
Okay, because the only SHR, the only explain definition. Now we come to the diagram. Diagram shows the sun at the center, the Earth is revolving around the sun, and from the Earth we are seeing the sun in the celestial sphere. So celestial sphere further away with the radius infinity. So when you're at E1 to the observer on Earth, the sun appears to be at S1. At this point, let it also be in line with Aries. As the Earth moves to E2, the sun will then appear to be at S2. S2. So what happens now from Aries? It is taken an easterly hour angle because west is this side. So the Aries, the SHA started reducing already. When Earth goes to E3, the sun would appear at S3 in the celestial sphere. S3. And the SHA is reducing further. When the Earth goes to E4, it will now go to S4. And finally, when the Earth goes to E5, it will go to S5. And once again, when the Earth comes to E1, it will go to S1. Therefore, we can see that the sun's apparent motion is largely easterly, making one apparent revolution of 360 degrees in 365.25 days in 1 year, and also SHA of the sun reduces by 360 degrees per year. That is 1 degree per day. And same thing if I draw here, I can explain in this also, where the sun, the Earth is here, the sun is here. It is also moving in easterly orbit, covering one full revolution in 1 year. That's all. Also, SHA would have been actually, this would have been SHA westerly. It going easterly, so SHA reducing actually by 360 degrees, and that way we say it is reducing by 1 degree per day. The diagram you can draw optionally. You can draw this, you need not draw this, but this is a must. The diagram is must. Right? Can I continue with the written work? Right.
Yes, sir.
Right on. The apparent motion of the sun is its motion as motion with reference to the Earth, not as seen, but we are seeing something else, with reference to the Earth. Referring to the figure, when the Earth is at E1, let the sun be at S1. When the Earth is E1, the sun will appear to be at S1. Let it be in line with first point of Aries. With Aries. As the Earth moves in its easterly orbit to E2, the sun will now appear to be at S2, thereby exhibiting an apparent easterly motion from S1 to S2. Since SHA is a westerly hour angle from Aries, we can say that the SHA reduces as the apparent sun moves from S1 to S2. अभी देखो ये समझा कि नहीं? Principle of navigation, tough question, easy answers, comprehension required. I hope everybody writing.
Last slide.
Yeah. SHA is a westerly hour angle from Aries, and the sun is moving easterly. Therefore, SHA reducing. Na?
Sir, last slide जो मिटा दिया सर वो एक बार
अभी तो उधर ही है. तो स्पीड
सर
बढ़ाओ.
इसमें जो अभी लाए हैं स्लाइड इसमें लेट इट बी इन लाइन विथ AR का मतलब
Aries. वही first point of Aries को AR. But you write full Aries. You can write your full with the Aries or the first point of Aries, whichever, it doesn't matter. It's also in short known as Aries. हो गया? Raj Shukla, done?
Yes, sir, done.
सर लिख रहे हैं सर.
Abdul Naeem.
Yes, sir.
Okay. Harshit Anand. Harshit, are you there?
Yes.
Done?
Yes, sir, done.
Okay. So now let me remove this top part. As the Earth moves in its easterly orbit to E2 तो already बोल दिया, E3, E4, E5 and back to E1, the sun would appear to have moved to S3, S4, S5 and back to S1, thereby exhibiting an apparent easterly motion from S2 to S5. Thus we see that as the Earth completes one revolution around the sun from E1 back to E1, the apparent sun one easterly revolution. The apparent sun also makes one easterly revolution in the celestial sphere from S1 back to S1. Again, don't try to see the sky and see ऐसा नहीं है. It is only theoretical actually. There's nothing practical about this particular topic. Other topics are practical, no doubt, but this particular one. Yes, C, thus we see, not D. Right. Can I move now? Let me know when you all are finished.
Okay, sir.
Everybody?
Sir, 2 more lines, sir.
Okay, लिखो.
Yes, sir. Clear.
Okay. Since the Earth, since the Sun completes one easterly revolution in 1 year of 365.25 days, we can say that the SHA reduces by approximately 1 degree per day. Thus, the apparent motion of the sun is easterly, completing 360-degree revolution in 1 day, in 1 year, and the SHA of the sun reduces by 1 degree per day. That's all. This is the apparent motion of the sun. किसी को कोई डाउट है तो बोल दो, completely लिखो, and as promised by 5:20 my topic is over.